Okay, so I'm gonna go ahead and get started. Really happy that y'all joined this afternoon. And so let's go ahead and jump in. So this idea, the dream, self-documenting APIs, if you follow Fielding's REST architectural style at face value and fully implement both hypermedia and optional code on demand constraint, an API specification wouldn't really be needed. The client wouldn't really need to be that smart, and the machine would be able to figure it out. But we are not there yet, and most of us will probably never be there. So we need something to talk to our machines. We need an API specification. So when I first started using a API specification, I was introduced to this idea of single source of truth. The very wordy Wikipedia definition of that is a practice of structuring information models an associated data schema such that every data element is stored exactly once. That's a pretty wordy way to describe it. I call it a contract, something that we all agree on. And that is important because what is OpenAPI specification? It's a contract. Just to get a gauge, who here feels like you could answer this question? I'm not actually going to call on you. Raise your hand, if you knew what OpenAPI specification is. Okay. Who is using it in your role somehow today? Okay. And then who knows somewhere within your organization someone is using it for something that isn't reference documentation? So this is why I'm giving this talk. It's a lot less hands. A lot of places haven't fully realized this yet. So I was first introduced to specs through API Blueprint about 5 years ago when I was a software engineer at a startup, and it was a very painful experience. I was trying to document from scratch an API that we wanted to open up publicly. I'm glad to say today this experience is a lot better. So what is OpenAPI? A very basic definition, and I'm not going to go super deep into it itself. I'm going to go more into what we can do with it, is standard structured approach for describing APIs that is both human and machine readable. It's a description of specific properties that then machines can process, but also we can read them as humans. It was initially called Swagger specification, but now it is a vendor-neutral specification under the Linux Foundation, and Swagger is more like a brand of tooling. And historically, it's been known something to auto-generate documentation. So why do I care about this thing? I'm the lead community engineer at Stoplight, where we help people design, test, mock, and document web APIs, where I help hundreds and hundreds of people use OpenAPI specification with some of our tooling, but also a wide range of tooling. Before that, I worked at Keen.io, which was a data analytics API company, where I helped manage our SDK and docs. And a lot of the things I'm going to talk about come from the pain points that I experienced through those things. So OpenAPI is a bridge to understanding and being able to communicate around using HTTP as a transport, and is our greatest hope for helping people learn their HTTPs and 123s. It's something that Ken Lane had said. And I really like this idea of it being a bridge, because for me, APIs are this intersection of where humans and machines are meeting, and so we need something to bridge that, and the specification can be that. So what are these hidden benefits? Especially for someone who doesn't want to write documentation, that's why they know it is auto-generating reference documentation. But I'm here to say it's not just that. So imagine you have a new API feature, and you need to update the server implementation. You need to update client libraries or maybe other consumers within the company, and maybe multiple languages. You need to update the docs. And above all those things need to be consistent with each other. And the front-end team right now is blocked because they can't implement that new feature. This is where these things come in. So it's a development contract. It's a bridge between teams. It removes some of the silos of the API development when everyone is working around some centralized contract. It's mocking. It's allowing technical writers and front-end developers and SDK maintainers and developer advocates and many others go ahead and start their work, which we'll cover a little bit more later. And it's also giving you more options on how to create SDKs and libraries. And it's all kinds of different testing, which we'll also cover later. And lastly, it's even ways to generate server stubs to start the implementation even faster. So it's more than a technical representation to me. It's a tool for collaboration. Filling in a spec is kind of like filling in a form, which helps simplify describing the API. Blank pages are really hard. Have you ever sat in front of a design doc and just had no idea where to start or what language to use? the specification kind of gives you some, terminology. It standardizes certain words. It gives us a language to communicate between teams. So I was once watching in a community Slack group some people talk about like endpoints and paths and operations, and they were all using different words for a lot of the same things. The specification gives us like a common language so that we can remove that friction of when we're talking about the same thing, but we're just not calling it the same thing. So I break this down, at least for this talk, because there's a lot of other things outside of this, to 3 different areas. So how can we use these ideas to make your APIs better? So first, design first. We take all these ideas and we're putting this into the actual OpenAPI document that's describing our API. This helps with consistency. It helps us to look at it from an eagle-eye view rather than it being pieced together. And there's 3 different ways that a lot of times people get a spec. They're either automating it from code, they're creating it through design-first principles, usually through a product or marketing team, or it's created after fact by someone else in the company, which is probably the most painful of all because you're having to write all of that from scratch. And I want to focus on the second one, but the first one of automating from code can be really helpful, especially if you have an existing API that you don't have a specification for. There's a lot of language-specific libraries out there that help you generate that, and then you can move over to design first for like new features and new operations that you want to add. But the code-first approach can be really expensive. We've all seen those APIs that like one endpoint is designed one way, and another endpoint part of the same API is designed in a totally different way, and it was really confusing to implement because we just assumed it was all going to be the same. This helps prevent that because you're starting to look at it at a higher level and all together in a document. And so also having that contract up front then leads to creating less versions that you need to go fix the problems you created the first time and less breaking changes that you're having to deal with customers and internal users. And just overall creates better developer experience. So once you've got that like design document, I'd say that one of the most powerful areas is being able to use that to mock APIs and get feedback. So at Stoplight, we say the mocking is routing incoming requests to example responses or dynamically generating examples on the fly. So think like being able to say, this is our min and max value for this integer, and it'll dynamically give some random number in those ranges or some kind of data format, so that users can actually, or internal developers can actually like see real responses without having to actually work on any of the API yet. A few mock servers are out there. I work on Prism at Stoplight. It's an open source mock server that's, there's other ones that are language specific. Node has one. Different tools also take in different things. So sometimes you're having to code out some of the mock server stuff. It's really helpful to find one that can just take your specification and you can start hitting endpoints. And a lot of times these include business logic too. So depending on your role, mocking can be important to you. So say you are using or building internal APIs, or even if you're exposing that externally for libraries and SDKs, you can build faster. You can start parallelizing development as both the provider and the consumer of the API. After the mocks are set up, then you can hand those off to teams, and front-end teams can go ahead and start seeing what they will need to do to implement those APIs. Instead of being in a more very waterfall-esque kind of development where teams are constantly waiting on teams to finish parts of the API, and you end up taking a lot longer. Once you've settled on it, you've gotten feedback on how you want to design the API, development can happen a lot more in parallel. And this, I've seen more and more front-end engineers are seeing the value in this, so they're asking their back-end teams to start giving them mocks sooner. If you write docs or tutorials, you can start writing sooner. So one of the things I experienced personally was if I needed to document a new API feature, the team was already working on it, they might clue me in to that was going to be happening. And then I could maybe get a very vague Google Doc that was a mess and I wasn't sure what the decisions were made. And then maybe I could write some docs for it. With having like a decided specification of like, this is how we're going to design this, I could have already started doing a lot of that work and had it ready for when they wanted to release it, versus that, oh, the docs are coming soon kind of situation that's like super awkward. There's also a really good technical writing blog called I'd Rather Be Writing. And Tom Johnson talks about how you probably actually have a lot more opinions as a documentarian or as a technical writer, or just anyone who's more customer-facing, because you are having to explain how that API works to them. And it's a great time to actually get more involved in the product process. Not all teams are receptive to this, but it's definitely an opportunity that's often missed. Oh, and the last thing, also interactive docs, so that like send a test request type functionality that can all be powered by mocking rather than having to hit the actual API and exposing that publicly. And then lastly, if you care about developer experience or advocate for users, which is hopefully everyone, you can power the feedback loops with mocking. Being able to get feedback earlier in the product process and being able to integrate that into the actual design. It can be so critical. You're also getting buy-in from whether that be an internal developer or an external user or some partner. And you're putting real endpoints in front of users instead of like hypothetical features that don't actually exist yet and they're not actually getting to try it out. If you're interested in like API design feedback loops, Capital One has actually a really good blog post about them. And the other thing is you can do mocking with the code first approach. You're just going to have to write a lot more code to make that even happen. And so Capital One has this idea of like experimental APIs. The same thing to me as like mocking APIs. And they use them to get feedback for their banking APIs within the community. And I've seen it build stronger relationships. So when that API comes out, partners are already ready for it versus it being like a brand new thing that they hadn't even seen yet. So since APIs are this mixture of humans and machines, a lot of times I think we forget that the people using our APIs are not really machines. They're actually humans that are telling the machines to use them. And so when getting feedback, that's just something to always remember. And some of the things to think about are what tasks are the users wanting to accomplish? Will the API help users achieve these tasks? Are they getting confused on endpoints? Do things make sense? Definitely, some of these could have prevented, I've seen some really bad APIs get released if they just ask these very basic questions. One way to do that is also having public OpenAPI specifications. Some people use that as like a centerpiece to their feedback loop. It's a new way to get kind of API feedback, whether that be on GitHub or some other medium. And you can get very specific feedback. They can tell you this exact operation does not make any sense compared to this one versus just being like, it's confusing, which is definitely something I've heard feedback from users many times. One thing I sometimes hear is people are reluctant to put out their OpenAPI specifications. And I usually tell people that it's just a map. It's not the key to the API, and you still need to focus on how you're actually implementing your API security. And security through obscurity is not great API security. So if that is why you're worried about putting out there, you might have bigger problems with your API security. These are just few companies that do public OpenAPI documents out there, various industries. There's hundreds and hundreds. There's repos on GitHub that just share other companies' OpenAPI documents, which can be fun to crawl through. And then the last thing is testing. So you need it, since it's machine readable, we're really taking advantage of that, of testing. It can mean a lot of different things, but I want to focus on linting and validation and contract testing. So a linter can act as a style guide for your OpenAPI document. Whether that be we want camel case and not snake case, and you can define that in your API style guide. And tools like Speci or Spectral, which we work on at Stoplight, can help you write custom functions and rules so that then you can use it to lint the document, which is actually then determining what is in the API. So you can bring more of that consistency that you're trying to look for with the design first. And then there's validation and testing. Tools like Dread. We do some stuff at Stoplight, Swagger Inspector. There's a few others out there. Some are language specific, some are more neutral. And you're not really just validating what is in the API. In a way, you're also validating what's in the API documentation, since everything is coming from that, or anything else. You're validating the client libraries and SDKs. So for me, contract testing is in validation testing. Some people use them and mean the same thing. And to me, it means that you're writing tests to ensure that the API or service meets some sort of standard and definitions that you've described in your contract. It describes what a successful response would look like when someone calls it, or whether like the libraries are actually implemented in the same way that the API is behaving. And so a very high-level view of that would be somehow an API gets called, endpoint gets called, you get a response body, compares that to the actual document, what the document says, and then the validation layer can decide if that passes or fails. An example would be maybe missing a required property that the document said it was supposed to have, but the API, for some reason, was implemented incorrectly. What I see this help a lot is less broken SDKs. At Keynote, I experienced the pain of this with our PHP SDK. Somebody came to me, it's not behaving the way they thought it was supposed to behave based on what the API reference said. I go to the API reference, and then I have to see what the API is actually doing, talk to the API team, was that even actually implemented the way they thought it was implemented? Then go back to the PHP SDK and find out 6 months earlier something got merged that totally changed the behavior of that function. If that was contract tested kind of in this format, the SDK code was updated, somebody opened a pull request, that kicked off a CI run, ran the contract test, and said, oh, that endpoint was missing, a property. And we would have fixed that immediately, and the SDK would not be broken, and now there wouldn't be hundreds and hundreds of users with an SDK that is not operating correctly. This is something actually SendGrid does for a lot of their SDKs. They're using Prism to contract test, and they have millions and millions of calls going through those. So the reality, who creates the specification? That's still a big one. Some teams have like a design council. Some it's like by committee. If your developers are on board and they see the benefits, like people are envious of you basically right now. Maybe they have no idea what the benefits are, so that's why I'm talking about it today, to try to help people start digging into some of these ideas. You only can cover so much in 20 minutes, but starting from scratch is not easy, but the tooling out there is definitely helping make that more possible. Project managers, I've seen, are our biggest allies because they see how the scope of this is much bigger than just these small little things like API reference docs or just mocks or just testing. And ideally, this is how things would look, but in reality, it's more like this, and you're like, it's not a cycle in any way. You're jumping around. But at least it's something to work towards. And you're definitely making your APIs better if you're already on some sort of the cycle. We still haven't figured out everything OpenAPI can do. What exactly is Infinity? I don't know yet. Linting, style guides, bringing it deeper into the development environment, CI, CD, all these different things. People are still exploring what tooling out there. Some say that we should be building better APIs. I think we should be striving for better API experiences because that includes more pieces of the puzzle, more areas of the business. And so my challenge is just to think what would help you and how could maybe an API specification do that. And there's my information. The slides will be up there. OpenAPI Tools is maintained by one of my teammates. There's a lot of tooling out there, language-specific tooling, neutral tooling. And I see a lot of environments, a lot of tool sets. If you want to talk about all your problems with trying to get your team to use specifications or anything like that, I'm happy to chat. Yeah, and that's it.